we're going to evaluate the integral of the square root of 5 plus x squared. We'll use trigonometric substitution. There are three types of trigonometric substitution integrals depending on what kind of a radical we have. In this case, our radical looks like square root of a squared plus x squared. So we have to match the a squared to 5. A very common mistake, many students assume that a equals to 5, which is not true. Most of the time we usually have a perfect square like 9 or 4, then we can take the square root to be 2 or 3. But this time we have a square equal to 5, which is not a perfect square, so a will be positive square root of 5, which is all we can say is it's square root of 5. Now the standard substitution is to let x be a times the tangent of theta. So in this case, x equal to the square root of 5 times tangent of theta. Dx is equal to square root of 5 times secant squared of theta d theta. And now let's replicate what's inside the radical. X squared becomes 5 tangent squared theta. And 5 plus x squared is equal to 5 plus 5 times the tangent squared of theta, and that's 5 times 1 plus tangent squared theta equal to 5 times secant squared theta. Now once we made these substitutions, the radical will go away, so we have the square root of 5 plus x squared, that's now 5 secant squared theta, times dx, which is square root of 5 times secant squared theta d theta. And so this is equal to integral of square root of 5. We can assume square root of secant squared is secant, so square root of 5 times secant theta times square root of 5 times secant squared theta d theta. And this simplifies to a known integral, something that you should know. Square root of 5 times square root of 5 is 5 times the integral of secant cubed theta d theta. Now this integral secant cubed is derived in the earlier video by using integration by parts. It's also derived by a reduction formula in several other videos. So if you don't know how to do it, look up a video that was done previously so you familiarize yourself with this integral. But I always suggest when you do integration by parts to evaluate this integral, because you'll need it when we do trigonometric substitution. So remember the integral of secant cubed and the integral of secant as you're doing trigonometric substitution problems. Okay, here we go. The integral of secant cubed is 1/2 secant theta times tangent theta plus 1/2 natural log of absolute value of secant theta plus tangent theta. So this is 5/2 secant theta tangent theta plus 5/2 natural log of absolute value of secant theta plus tangent theta. So let's revisit our integral that we started with. The integral was the square root of 5 plus x squared. We made the substitution. The substitution was x equal to the square root of 5 times the tangent of theta. Once that substitution is made, we're able to solve the problem. We end up with 5/2 secant theta times the tangent theta plus 5/2 natural log absolute value of secant theta plus tangent theta. This is an answer in variable theta, but the integral was in variable x. We must have final answer in variable x. So this is going to be, back from our substitution, let's go back to tangent of theta. It is x divided by the square root of 5. I'm going to draw a right triangle, looks like this. Call this angle theta. Tangent of theta is opposite over the adjacent. So if I let opposite side be x and the adjacent side be square root of 5, I have that. Then the hypotenuse, I hope everybody can see that that's going to be exactly the radical from our integral. It's square root of 5 plus x squared. We can easily check that by Pythagorean theorem. So now for the final answer, the integral of the square root of 5 plus x squared is equal to 5/2 times secant. Secant is hypotenuse, that's square root of 5 plus x squared, divided by the adjacent square root of 5, times a tangent, which is x divided by the square root of 5, plus 5/2 natural log of secant, so that's square root of 5 plus x squared over square root of 5, plus tangent, that's x over square root of 5. And this is equal to, simplifying, the 5 here and this 2 square root of 5's cancel. So the final answer is x times the square root of 5 plus x squared. There's a 2 left, so divided by 2, plus 5/2 times the natural log of absolute value. We can have this one radical 5 plus x squared over square root of over 5. We've combined the radicals, plus x divided by the square root of 5, and then add a constant of integration at the very end. For more videos